welcome to an introduction to algebra. Okay, what is an equation? An equation, and I think I went over this in one of my earlier videos. An equation is a mathematical statement using an equal sign. So it's just a statement using numbers and operands and an equal sign. Now, I will write up a few examples here, which you'll already be familiar with. 6 plus 5 equals 11. That's simple enough. The second one down here, 22 minus 12 is equal to 10. The third one, 6 times 2 is equal to 12. And the fourth one, 18 divided by 6 is equal to 3. So I've decided to use addition there, subtraction, multiplication, and division. Very simple examples. All are mathematical equations. And all have an equal sign, right? Now, these you're already familiar with, very familiar with. Now, if we rub out these numbers, right, and replace them with a space, that too you are already familiar with. You've already had these sorts of problems given to you to solve, and I don't think you've had too much problem doing them. Okay, right, so if we were given something like this, then because these are fairly simple, and in the past you would have got fairly simple ones, similar ones, 6 and 5, you can already do that. 5 and 5 is 10. Just add an extra 1 because 1 is a 6. And of course you get 11. 22 minus what is equal to 10? You know this 22 is made up of 10 and a 12. So you know that if you take out the 12, you get 10. 6 times something equals 2 equals 12. Out of your 6 times table, 6 1 is 6, 6 2 is 12, right? So you know that is supposed to be 2. And 18 divided by 6. 18, if you split it 3 ways, divided by 6, so 6 times something equals 18. Again to 6 times table. We know 6 2s are 12, 6 3s are 18. So if you divide 18 into 6 equal parts, each of those parts will be 3. Okay, sorry, I think I might have accidentally said 3 earlier, but carry on. Now, if we then imagine that instead of the space that we put a letter to represent the number that we don't know. So that instead of you getting from your teacher before the space, now we put a letter. And we'll start with the letter that we use in algebra most frequently, and especially when you start doing algebra, and that's X. It's that number we don't know, X. Okay. Right. Okay. Now, this is when we start getting into algebra. Now, if we if we go to the definition of algebra, I'll just read it out because I can't even remember it. Mathematical system using symbols, especially letters, in this case it was used in X, to generalize certain arithmetic operations and relationships. It's a mouthful. That's why I had to read it. It sounds complicated. But if you put it simply, it's if you have an equation, it will have one or more letters replacing numbers. So here you have an equation, and you've got one letter there that has replaced a number. But in algebra, it might not just be one letter. It can be more than one. Right? That might sound complicated initially when they say in the definition where you use the symbols or the letters to show relationships. Okay? Relationships between two different things. I'll show you a very simple example from everyday life. I don't know how old you are. I could guess, but I don't know for sure. But say that you had an older brother or older sister. But let's say in this case, older brother. And your older brother was 5 years older than you. So say, for example, and I write it down here, A is your age, right? B is brother's age. If we were to use these letters in a mathematical equation to show the relationship between the two ages, and important thing to know here is note here that at this point we don't know what your age is, and we also don't know what your brother's age is. We can write a mathematical and algebraic equation to say A, which is your age, plus 5 is equal to B, your brother's age. So your age plus whatever that is, plus 5 years is equal to B, is equal to your brother's age. So that's all the definition of algebra really meant. And this is a very simple relationship. In complex algebra, which you will learn far later on down the track, in many, many years' time if you continue with complicated maths, is that this is very simple. You'll get very, very complicated algebra involving many operations, many variables. So variable is this, something you don't know the value of. And so that's the very simple everyday example I can show you right away, just to introduce you to the idea of variables showing a relationship between two different things. Right. Now that we know this, I'll rub this off just to clean the board up a bit. Okay. Now we return to these examples that I had already done before. Now, there is a certain technique that you can use to find out the value of x. But the first thing you've got to do is you will have to play around with the equation so that you can find out what the value of x is. Okay, so in this particular example, 6 plus 5, we've already done it before. We know it's 11. So we will write down x is equal to 11. That will be the solution. Here, 22 minus x equals 10. Now there's what you do with an equation, and I've also covered this in one of my earlier videos, once you have the equals in the middle, what you do to this side of the equation, you must also do to the other side of the equation. Exactly the same thing you must do on both sides in order that this equal sign still be applicable. In order for this side to still equal this side. So, in this case, if we have minus x on that side, what we can do is put plus x on that side, right? And also plus x on this side, right? This will mean then that we have 22. So these two have cancelled each other out. Is equal to 10 plus x. And then what we can do is then minus 10 on both sides. I'm just showing you an abbreviated form here of solving because there isn't much space here right now, but this is just a quick way, and then I'll work through some proper examples later. So now you have 22 equals 10 plus x. If you minus 10 from both sides, this 10 here will cross out that 10, just like that x crossed out that x, cancelled it out. So now you have x. I've just taken it to this side, now I'll take this side over to that side. 22 minus 10 is equal to 12. So you're ending up with the exact same answer, but you're just playing around with the equation. So doing same thing to both sides in order to make one side only say x. Here's 6 times x. There's another thing that happens in writing out mathematical, especially algebraic equations, where if you're saying 6 times x, another way to write it, and in fact the proper way to write it, is 6x. When you see 6x, you automatically know it means 6 times x. So 6 times x is equal to 12. So all you do is divide both sides by 6, so 6 times x, but if you divide by 6, that crosses both the 6's out, but you also got to divide 6 here. So you're left with x on this side is equal to 12 divided by 6 is equal to 2. So that's the answer there. Now over here, mind you, this is the third time I'm showing you these same answers, but just showing you a different way of getting to the answer. Now 18 divided by 6, 18 divided by 6 is 3 from your times table. So here it's fairly simple. There's one thing I'd like you to show too. If you have one side of the equation saying something and this side of the equation saying something, you can take all of these things, put it on that side, and take all of these things and put it on this side. And change nothing else. Just like swivel the whole equation. Because it's similar to saying 3 oranges equals 3 oranges. It doesn't matter if this side says something and this side says something, and you switch them, because at the end of the day, what's on this side is the same as what's on this side. That, what I've just explained to you, is very different from multiplying something here and the same thing over here. It's quite different. I'm just saying sometimes when there are x's over this side, you can put the x on this side and put whatever's on this side on the other side. That's quite valid. That's a valid thing to do. So here you can write x is equal to 3. Now let's work through some proper examples. For examples, I was just showing you, introducing you to one variable in an algebraic equation and how to solve for it. Solve for x. if we go to first example, 9 plus x is equal to 14. This now I'll take good space everything out, and make it a bit clearer, because I know it was a little bit tight in the last 4 examples. So what I will do is again do the same thing over this side as I do over this side in order to get rid of some things. So this has got a 9 here. In other words, it's a plus 9, right? So 9 here, so I can minus 9 on both sides. So 9 plus x minus 9, right, is equal to 14 minus 9. So I've done the same thing on both sides here, right? This 9 here cancels out this minus 9. This is a plus 9. If it doesn't say minus 9, it is a plus 9. So plus 9, minus 9, the 2 9s disappear. So you only have x on this side, and this side 14 minus 9, you have 5. That's your answer. But wait, you can test. You can test properly. So test. If this is really the answer, then if I put this 5 where that x is, then the equation should read true. Okay, so let's write out that equation, but now we put 5 where the x is. 9 plus 5 excuse me, is equal to 14. Does that make sense? Is that true? 9 plus 5 is equal to 14? It is, isn't it? So it confirms this is the correct answer. Okay, on to the second example. This time with subtraction. (45) minus x is equal to 10. So first thing I'm going to do is move the x over to this side. There are easier ways of showing this, but in this situation I'm going to show you everything step by step. So once you know the basics, you can attack any problem, but then down the line you get shown the shortcuts. So 45 minus x plus x. Right, so I want to take the x from this side and put it this side. So I have put plus x on both sides. Right? So this minus x and this plus x cancel out. Plus minus the same thing ends up being 0. So now we have 45 is equal to 10 plus x. Now I want to take this 10 and take it over the other side. How do I do that? There's 10 plus x and minus 10. Sorry, let's get it tight there. Minus 10. So that these two can cancel out. So this is what I'm introducing here, minus 10. So here 45, and I'm doing the minus 10 as well over here. Right? Same thing on both sides, minus 10. This plus 10 cancels out this minus 10, and we're left just with x. 45 minus 10 is equal to 35. So what you've left on this side is 35, and here you've left x. Switch them around. So now the x is on this side, and now you'll put the 35 on this side. 35 being, of course, 45 minus 10. So what we will now do is the test, and we will put this x value into here. So we'll put 35 instead of the x. We'll write it out. 45 minus 35 is equal to to 10. You have to ask yourself, does that work out? Does it make sense? Is it true that 45 minus 35 is equal to 10? And the answer is yes. So that works out. And that looks like the correct answer. The third example. 8x is equal to 24. I'd already told you when we were going through the quick examples before that 8x would mean 8 times x. So 8 right up next to a variable. If it said 8a or 8b, then that would be 8 times a or 8 times b. So here 8x is the same as 8 times x. Okay. To simplify it, I will divide both sides by 8. Right? 24 divided by 8. So I've done the same thing over this side as over this side of the equal sign. And you're left with x here because these two have cancelled out. The times 8 and the divide by 8. So you're left with x, and over here, 24 divided by 8. So 8 times what is 24? 8 ones, 8, 8 twos, 16, 8 threes are 24. But we test. So 8, and we have x, so 8 times 3 is equal to 24. 8 times 3 equal to 24. Sounds correct? And then the fourth example, which is using division. 42 divided by x is equal to 6. Now if it's divided by x, then I want to times it by x, right? So that I can get rid of the x from this side. And then it of course takes the x onto the other side. So 42 divided by x times x, which means it's x over 1, right, is equal to 6 times x, which is the same as saying 6x, right? So I've multiplied by x on both sides. Multiplied by x, multiplied by x. This divide by x and times x cancel out. It leaves 42 over 1, which is the same thing as 42. Any number over 1 is the same thing as itself. 42 is equal to 6x. Now I need to get rid of this 6. This is 6 times x, so I'll divide both sides by 6. Right, so that these two can cancel out. And now I'll have only x on this side. 42 divided by 6. So it means 6 times something equals 42. 6 are 36. 6 sevens are 42. Right? So this is actually 7 and this side is x. So we just flip it. So x equals 7. But we still test. We'll write the equation out again, but this time with the number that we found out, with the variable value. So the value of the variable here that we've discovered is 7 is equal to 6. 42 divided by 7 is equal to 6. Is that true? Yes. 7 times 6 equals 42. 42, if you divide it into 7 equal parts, you'll get 6. Right. Okay. If you found the video useful, please like and subscribe for notifications. Thank you for watching.